Hi everyone, today we'll see what exactly a Kirchhoff's current law is. So, the Kirchhoff's current law is defined as the total number of currents or the sum of the currents which are entering any node is equals to the sum of the currents leaving that node. That means now if I am taking a node here, example I am taking one node. So before going to the clear explanation of the Kirchhoff's current law, first of all we need to know what exactly a node is. So it may be a node, it may be the interconnection of two or more branches. Now let us take a point here. This is a point where 1, 2 and 3. Let us take 3 examples. Now 3 branches are entering the node, then a point, that point is called as a node. Now if we see this, so a point where two or more branches meeting together to form a node. That is what how we define a node is. Now coming back to your Kirchhoff's law, what it is saying is the current states that the sum of the currents entering into any node is equals to the sum of the currents which are leaving that node. Now if you see this example, now I have three currents, I1, I2 and I3, which are entering this node, and this should be equals to the IT. That means now the currents I1 plus I2 plus I3 is equals to IT. Now so therefore IT is equals to I1 plus I2 plus I3. So this is how we are defining a Kirchhoff's current law. Now we'll see with a small circuit. Now I am taking a current IT which is entering a parallel resistor combination circuit, and let it be I1, I2 and I3. Now this is connected to a voltage source Vs. Now according to my Kirchhoff's current law, what it says is the total current IT is equals to I1 plus I2 plus I3. Now this is at this particular node, that is IT, the total current which is entering here is equals to I1 plus I2 plus I3. Now when it is coming to the node 2, the total current I1 plus I2 plus I3 is equals to your IT. This is how we are defining our Kirchhoff's current law. The other way of representing the same Kirchhoff's law is, now I am taking one junction or a node at which three branches are entering the node and two branches are leaving the node. Let us take, I am giving the current notations as I1, I2 and I3. Let us take this is I4 and I5. Now if you see here this particular example, now how I can define my Kirchhoff's current law is the sum of the currents which are entering the node is equals to the sum of the currents which are leaving the node. So I1 plus I2 plus I3 is equals to I4 plus I5. We can also say that I1 plus I2 plus I3 minus I4 minus I5 is equals to 0. Now with this we can define the Kirchhoff's current law as the sum of the currents, the algebraic sum of the currents at a particular node is equals to 0. This is how even we can define our Kirchhoff's current law. Thank you.